Hi, I'm Sven, and today I will show you a little bit of details about our new Edge AI demonstrator using an Automotive Infineon TC4 microcontroller. In this application, which you can see here, this is a typical power system of a car, starting with the onboard charger, where you have a power factor correction unit, a high voltage to high voltage DC-DC converter, and a high voltage to low voltage DC-DC converter as well. You see, Infineon can provide a couple of products, be it on the power stage, the digital parts, the microcontroller, gate drivers, isolators, sensors, and of course, low voltage MOSFETs, which Infineon is very proud of. In the system here, we look at this low voltage DC-DC converter on this little PCB here. This is the so-called power converter kit, where we have our Infineon TC4 microcontroller, which controls here this DC to DC converter. In this example, it's only a low voltage system, but in theory, you could also scale it up to higher voltage classes, like in trains, in cars, whatever your application is. On the screen here, you can see one of the example measurements which was done. We have here a couple of loads, and you see the example, the comparison between using a static system, which has static control parameters, and this is the green line. When there's a load jump, you can see here the voltage is oscillating and the overshoots are quite high to the upper limit and the lower side. The current as well. Here also the green line, you can see oscillation is clearly visible. And in both cases, you can see that it takes a significant amount of time to actually reach the static point, which would be our desired result here. In comparison, using this purple line here, you can see the Infineon technology, which is a neural network running on the AURIX TC4 microcontroller. And with this technology, we have no effort to optimize the overall system behavior, which is getting a more stable output after a load jump. And the advantage here is you can keep most of the system as it is today and just use this neural network executed on the AURIX TC4 PPU, the parallel processing unit, which is an optimized hardware unit for executing neural networks. And the result would be here that only the control parameters are actually modified on the fly over the complete life cycle of that control system. And after the first switch on, you can directly see the impact. The peak-to-peak overshoots and undershoots are a lot smaller than when you can see with the traditional approach with static control parameters. And also the time, which is kind of here, is a lot shorter than with a traditional system like here. And the benefit of this overall system would be that your system can run much smoother, so it's more efficient. You have less stress on the power conversion unit hardware, and you can do optimization without a heavy invest in new training for AI networks and anything else.